So today we started our last unit before the EOC, and that is going to be the statistics unit. So we're going to start with the basics of statistics. So what is statistics? It's going to be the study of how to collect, organize, analyze, and interpret information from data. Now the great thing about data is it's any question that I could ask. What's your favorite color? And when you answer, that is going to be a data point. What size shoe do you wear? When you answer, that's going to be a data point. So what is data? It is either a fact or a figure from which conclusions can be drawn. Now I have two different types of data. We have qualitative or categorical data, and we have quantitative. So when we see the word qualitative, you want to think about the word quality. And this is going to be a non-numerical data point. So an answer such as, what's your favorite color? Blue. Well, blue is not a number, therefore that is a qualitative data point. What's your favorite candy bar? And if you say Snickers, then that would be a non-numerical answer. You have to be careful of things that are numbers but don't really have a value when we talk about categorical data. So jersey numbers are going to be considered categorical because even though they are a number, they don't carry value. Just because someone wears a number 5 on their back doesn't mean that they have value of making 5 goals in a game. That is just a way to describe them. So again, qualitative or categorical data is going to be things like colors, candy bars, or jersey numbers. When we get to quantitative data, you think about quantity. So if you go on Amazon and you order something, you see a little box at the bottom that says QTY, that's quantity. How many do you want? So this will be numerical data points. Things such as height, test scores, or shoe sizes. So now that we know what statistics is and what different data points are, how are we going to get this data? We have two different sources where we can get the data. One is going to be the population, and the population is going to be all measurements of interest. So population again will be all measurements of interest. Now this can be a large-scale population or it can be a small-scale population. If we're talking about the population of students in my third period classroom, then those are 26 students. All 26 are considered to be the population. If I consider the population of Oconee County High School, that is every single student enrolled in Oconee County. I can also take it even more broad, and talk about the population of the world. So that would be every person from fresh newborn babies to people on their deathbed. Every person would be included in that population. When we talk about a sample, this is going to be a collection from the population. Now again, if we go back to students in a classroom in third block, I could take 5 students drawn randomly out of a hat, and that would be a sample of that population. If I'm looking at the population of all Oconee County High School, then I could take a sample of the freshman class. That is a collection that comes from the population. So now we know what data is, we know who we can get it from, so we need to talk about the types of statistics there are when we have this data. So descriptive statistics calculate specific statistical values based on the given data. And that data can come from either a sample or a population. So for instance, test scores. After every test, I type every person's test score into a spreadsheet and I analyze the class average for the test, and then I make all of my students that I teach. I take their averages and compare all of those. So those would be descriptive statistics because that comes straight from data from the sample, or if I take all of my students, that would be the population. Now there's also inferential statistics, and this uses a sample to make an inference or an educated decision about a population. So if I were to ask just my students, which do you prefer, hot dogs or pizza, and pizza wins, then I could go to the cafeteria and say, well, OCHS prefers pizza based on the sample, because that sample comes from the population. So that's going to be an educated decision based on the information from the sample. There's two different ways that we can represent the statistics. The first way is going to be a frequency distribution. This is simply just going to be a table. This table is going to be an organized list that tells me how often a particular event occurs. So make sure that you have one of your sides to be frequency to tell me how often that occurs. The other thing is going to be a histogram, and that's going to simply be a graph. And this is going to be a graph that shows the frequency of an event. Using bars. So if we look at example 1, we have results from an algebra test. And we have all these scores that were on an algebra test. Well, before I can create the histogram or the frequency distribution, I have to determine my bin size. So I'm going to make a bin size of 5, meaning there'll be 5 numbers when I calculate the scores. So I'll start with 55 and go to 59, then I'll use 60 to 64, 65 to 69, 70 to 74, 75 to 79, 80 to 84, 85 to 89, 90 to 94, and finally 95 to 99. You might be saying, well, that's only 4 numbers, but think about it. We have 55, 56, 57, 58, 59. There's really 5 numbers between those two barriers there. So as I go through the list, I'm going to put the bin sizes that I've created over here. So 55 to 59. We've got 60 to 64. 65 to 69, 70 to 74, 75 to 79, 80 to 84, 85 to 89, 90 to 94, and then finally 95 to 99. So as I look through their list, I want to find how many numbers fall between 55 and 59. And I can look that only happens one time. How many numbers fall between 60 and 64? So there are none of those. Between 65 and 69, that'd be right here, there are 2. 70 to 74, that's going to be 3. 75 to 79, 3. 80 to 84, so that's all of these numbers here. There should be 11 of those. 85 to 89, here, there's only 5. 90 to 94, 4, and then 95 to 99, there's 6 values. So that's all you have to do for a frequency table or frequency distribution. You tell me what is being represented, so scores on the test, and then the frequency of how often those scores occur. Now for the histogram, I always have to make sure I have a title of my histogram, so these will be test scores. My x-axis will be the scores, and you want to make sure that you label those. I'm going to start here at 55, and we'll just go up by 5s on the bottom. That's 70, 75, 80, 85, 90, 95, and we'll put 100 off the end. But then I'm also going to have to make sure that I label my y values, and these are the frequencies. And I want to make sure that I'm able to get each one of these, so I'm going to do it by 2s on the side, so that I will be able to evaluate all the frequencies from my table. So at this point, I simply just want to make bars based on what I see. Between 55 and 59, there is a frequency of 1. 60 to 64, 0. 65 to 69 is 2. 70 to 74 is 3. And notice that my bars here are actually touching. There's no gap between these. And the only reason there's a gap between 60 and 65 is because the frequency is 0. So 75 to 79 is going to be another frequency of 3. 80 to 84 is a frequency of 11. 85 to 89 is a frequency of 5. And then 90 to 94 is 4. And finally, 95 to 99 is a frequency of 6. And so that's all I have to do to create the histogram. Again, we've just talked about frequency distributions and histograms, and frequency distributions and histograms can use both qualitative and quantitative data. So I can use colors, I can use numbers, I can use any kind of category with frequency distributions and histograms. So when we look at stem and leaf plot, that's simply another way to organize and display data. That's going to show things from the original data point. So we won't be using groupings, we'll be using the exact points. And we can also compare two data sets by creating a side-by-side or a back-to-back stem and leaf plot. Stem and leaf plots can only be used with quantitative data. So numerical values is the only thing that we can look at when creating a stem and leaf plot. So let's look at example 2. We have the ages of people who took a survey. Now for the frequency distribution, I want to be able to create these bins, so groupings of numbers. I can tell that my lowest number is 25, while my highest number is 42. So I'm going to make these in a bin size of 4. That's going to be my bin size. So I'm going to start at 25 and go to 28. Then I'll go from 29 to 32, 33 to 36, 37 to 40, and 41 to 44. Okay, so now I just want to go into my data set and see how many numbers are between 25 and 28. So I have 1, 2, 3, 4. So 4 values would be between 25 and 28. Now I'm going to look at numbers between 29 and 32. So 1, 2, 3, 1, and 4. So there'll be 4 values between 29 and 32. Now, between 33 and 36, find these values, there's going to be 5 of these. Numbers between 37 and 40, and no numbers between 37 and 40. and then 41 to 44 will be 3 of those. So when I get ready to make my histogram, my title is Age of People Who Took a Survey. My x-axis will be ages. My y-axis will be my frequency. I can tell from my frequency table that I'm not going to need to group my numbers on the frequency chart. I can just go up by ones. And I'll start at my ages, 25, 29, 32, 36, 40, and 40, 42, 41. 33, 37, 41, 45. We just want to make our bars and these groupings. So the frequency of 25 to 29 or 28 is 4. From 29 to 32 is 4. 33 to 36 is 5. 0 between 37 and 40. And 3 between 41 and 44. This is just practice of making a frequency distribution and a histogram. Now we're going to add in the stem and leaf plot. I'm going to need my original data points. That's how I'm going to create this. And then in my stem and leaf plot, I want to look at my 1s and 10s values. So the things that become the stem are my 10s values. I've got 2s, 3s, and 4s, 20s, 30s, and 40s. And then the 1s units become my leaves as we go through this. So I'm going to start in the 20s. Sometimes it helps if you identify each one that's here. I have a 25. So the way that I represent 25 is I just put a 5 on the other side of my stem. Then I've got a 26. Another 26. Another 26. Then 29. And another 29. Then I move to my 30s. 30. Another 30. 34. Another 34. 34. Then I have 3 35s. 1, 2. Finally, when we look at our 40s, we have 41, a 41, and a 42. Now the last part of this is you have to make a key that's going to go with it. So we can pick any number on the list. So let's say 2, 6, and tell me that this represents 26 years of age. Now if we talk about this back-to-back stem plot, we're going to have results from 2 different classes on their algebra test. So I still need to label this. This is a test that they've taken. We'll put Class A's answers on this side. We'll put Class B's answers on this side. Now if I look, I have to consider all this data together. So the lowest number between both of those classes is a 59, while the highest answer is going to be a 96. So I'll have 50s, 60s, 70s, 80s, and 90s. So we just start with Class A. On Class A, we have a 63, we have a 67, 74, 75, 75, 76, 77. As far as my 80s, I have 84, 87, 88, 88. And then I go to the 90s. I have 90, 90, 94. All right, get ready to look at class B. Okay, I have a 59, 65, 65, 73, 76, 79, 79, and we have 83, 83, 86, 88, 89, and then for our 90s, 94, 95, and 96. Now we still need to make a key for this, and you can pick any of these values. I'm just going to pick 95 will give me a 95% on my test. Let's move on to something that should be a review for you. So different important statistics. So what do we call the average set of all terms in a data set? Well, this is going to be the mean. And in your calculator, this is going to be denoted by X bar, so an X with a line on top. The middle number in a data set, when it's arranged from least to greatest, is going to be what we call the median. Think about when I'm driving down the interstate and it has the sign that says, keep off the median. That's the grassy area in the middle of the road. And in the calculator, it'll be denoted as MED. Finally, the number or numbers that occurred most frequently or most often is going to be the mode. Unfortunately, our calculators will not tell us what the mode is, but you should be able to look in a data set and tell me what happens the most. Now, mean, median, and mode are all measures of center. We also call this measures of central tendency. So this means what we're trying to do is find the value that best represents the center of the data. So we're going to discuss the shape. So the overall shape of a graph is going to be called the distribution. And the shape of the distribution is referred to as skew. So we can use a dot plot to help us determine the skew. So let's look at these three dot plots that we have and discuss the skew. Now what I like to do is trace the outside of my dots to see what's happening. That'll help. Now let's start with the one here in the middle. This is similar to a parabola, so it's going to be symmetrical. You could also call that normal or bell-shaped. Now I like to draw a little Godzilla for each of these and think about his tail. And in this direction, you ask yourself, what direction is the tail pointing? And it's pointing to the left, so we call this data skewed left. And then we're going to make our little monster Godzilla here. We think about which direction his tail is pointing. That is to the right, so we consider this skewed right. So the values will typically fall in unique order, depending on the shape of the data set. So if we're looking at a data set that is skewed left, the first thing we'll see is the median, then we'll see the mean, and then the mode. If the data is symmetrical, the mean, the median, and the mode should all be the same in the middle of my data. And then if it's skewed to the right, then I should see my mode first, what's occurring the most, then the mean, then the median. So let's put everything that we've done into one problem. So example 5 here. We have the results of 3 different tests. They want us to create a dot plot from each using 10-point intervals, and then find the mean, median, and mode of each. So all I'm going to do is look at data set 1 here, and I'm going to put it on the dot plot that goes along with set 1. So this wants us to do it in groups of 10. So there are 2 scores in data set 1 in the 40s. There are 5 in the 50s, 5 in the 60s, 3 in the 70s, 2 in the 80s, and 1 in the 90s. Then we move on to test 2. We have 1 score in the 40s, 4 scores in the 50s, 5 in the 60s, 5 in the 70s, 4 in the 80s, 1 in the 90s. And for test 3, 1 in the 40s, 1 in the 50s, 3 in the 60s, 5 in the 70s, 6 in the 80s, and 2 in the 90s. So now what we want to do is describe the skew of these graphs. So what is the shape? So you can trace the outsides. This will help you to determine. You can tell that this is skewed to the right, and no one is symmetrical, and the last one is skewed to the left. Now, it's also asking me to find the mean, median, and mode of each of these, so I have to go back into the original data set. So I'm looking back at these numbers that were given here. To find the mode of each of these is pretty simple. So I just want to look in data set 1 and say, okay, what number is happening the most? And for mode for number 1 is going to be 50. For test 2, I can look, I've got 68, and we also have 89. So this one is going to have 2 modes of 68 and 89. If it has 2 modes, we call this bimodal. That's 2 modes. And for test 3, if I look, the mode is going to be 85. Now to find the mean and the median, you need to go into your black calculators. There's a button that says data. You need to press that button, and when you do, it's going to come up with 3 different columns. It's going to be titled L1, L2, and L3. So we're going to do one test at a time. So we'll take the data points from test 1 and put them into L1. So 43, enter. 45, enter. 50, enter. 50, enter. We'll do that for all the points all the way out to 95. When you finish, you're going to press the second button, the light blue button, and then you're going to hit data again. And when you do that, you should see a list that says stat bars, 1 bar stats, 2 bar stats. You want to arrow down to 1 bar stats. When you do that, you should see L1, L2, L3, and then it should say frequency. You just want to hit enter, enter, enter. And when you hit enter, 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 on your screen you should be a list of numbers. The first thing that you should see is n equals 18. So that means that there are 18 data points that you just put into your calculator. The second thing that you should see is that the mean is 65.44444. So it's going to say x bar equals 65.44444. And we're just going to write that as 65.4. And if you arrow all the way down, you keep going, you'll see MIN, Q1, and then after Q1 you should see MED. That's going to be the median. So for test 1, the median is going to be 63.5.